Reliable AI tools don't start with clever prompts. They start with contracts, clear schemas, strict validation, and outputs machines can trust. In this module, we'll turn MCP tool interfaces into predictable, safe connections between AI clients and real systems. So far, we've built the foundation: what MCP servers are, how they run in production, and how to secure them with strong access controls, isolation, secrets handling, and audit trails. We also designed AI-facing tools with clear intent and safe boundaries. Now we'll make those tools dependable through schemas, runtime validation, and structured outputs. A schema is the production contract between what the AI wants to do and what the server will actually run. It turns a natural language intention, like send an email, into an allowed shape. Required fields, valid types, constraints, and semantics. That contract gives the client safer boundaries for generation, and gives the server a clear basis for validation and enforcement. In production, strong schemas also make behavior observable and testable. Treat schema design like API design: intentional, reviewed, stable where possible, and versioned when it changes. For inputs, the contract becomes concrete field by field. Each field needs a specific name, a type, and a description that explains how to use it. Required should mean truly required. The tool cannot run safely without that value. Constraints, like allowed categories or minimum numbers, help catch bad calls before they reach business logic. Avoid vague catch-all parameters like query or metadata. Specific fields give the AI better guidance and make server-side validation predictable. Required means the operation cannot safely proceed without this. A customer ID is required because the server cannot know whose record to update. Priority might be optional if normal priority is a safe default. The danger goes both ways. Too many required fields create friction and failed calls, while too many optional fields create guesses, ambiguity, or hidden behavior. Document every default explicitly and reserve required status for data that affects validity, safety, or meaning. Good schemas do more than name fields. They shrink the input space. Enums are best when a choice must come from a known set, like status or region. Format rules catch values that should look like emails, dates, UUIDs, URLs, or timestamps. Pattern matching handles structured strings, such as codes or IDs. Length limits stop accidental bulk input and make injection-style payloads harder to pass through. Numeric ranges keep quantities, page sizes, retry counts, and thresholds within safe bounds. Every constraint turns a vague request into a smaller, safer contract before the tool ever runs. Production tools often need inputs that look more like real data than simple form fields. Nested objects are useful when fields belong together, like an address or a date range, because the structure tells both the model and your server what must travel as one unit. Arrays need tighter contracts. Define the item shape, allowed counts, and whether duplicates are acceptable. But depth has a cost. The more layers you add, the harder generation and debugging become. For conditional inputs, use a clear discriminator, like trip type, so each variant exposes only the fields valid for that choice. Schema descriptions are part of the instruction surface for the model. A weak description like number of items leaves too much room for guessing. A production-ready description explains the meaning, allowed range, defaults, units, and examples. That guidance helps the AI choose the right tool and generate safer arguments. It also tells the model when not to use a field, which matters for optional or high-impact parameters. Treat every description as operational guidance, not decoration. If humans would ask a follow-up question, the model probably needs more detail too. Now shift from design time contracts to runtime enforcement. The schema is not a security boundary by itself. Every tool request still needs to be checked by the server before anything useful happens. First, validate the structure. Required fields, types, ranges, and allowed values. If that fails, reject early and log safely, without exposing sensitive data. If it passes, move on to authorization, policy, and business rules. Keep those checks separate because they answer different questions. Only after all gates pass should the tool execute and return structured output. Validation is not always a hard no. Some values are merely messy, like extra spaces, different casing, or a date format you can parse unambiguously. Normalize those into one canonical form so the rest of the system stays consistent. But reject anything ambiguous, lossy, or risky. Tenant identifiers, authorization-related fields, oversized payloads, suspicious expressions, or dates with unclear meaning. Normalization should never change intent or expand access. Make the rules deterministic, documented, and easy to audit. Validation errors are also part of the API contract. If an AI client sends a bad request, don't just say invalid input. Tell it exactly where the problem is, what rule was violated, and what value shape is expected. A good response includes a stable error code, a short message, and field-level details like date range, a start or filters, to Ford operator. When it is safe, return all correctable issues at once, so the client can retry once. But keep boundaries firm. Never expose secrets, internal logic, or policy details. Once a tool executes, the response needs the same discipline as the request. When output may be used by an AI client, treat it like an API contract, not a paragraph. Put the actual result in a predictable data object. Keep metadata, warnings, and suggested next actions in separate fields. Most importantly, preserve the same shape whether the call returns full results, no results, or partial results. Empty data should still be data, not a different response format. This lets clients parse confidently, handle edge cases cleanly, and show user-facing text without confusing it with machine-critical information. Strong outputs don't just return data. They tell the client what happened, what object was involved, and when it happened. A status field should be explicit. Success, partial success, not found, or queued are easier to handle than vague messages. Stable resource identifiers let the client store, update, or troubleshoot the right record later. Timestamps should use one consistent format, ideally ISO 8601 with time zone information, so systems don't guess. And when operations cross services, include a request or correlation ID. That small piece of metadata often becomes the fastest path through logs, support, and audits. Here's what that looks like in practice. When a tool only says completed with errors, the client has to guess what happened. A better structured response separates the facts from the guidance. For bulk update contacts, return status, partial success, updated count, 87, and a failed items array for the 13 contacts that did not update. Add warnings for non-fatal issues like skipped records or stale data. Then include next actions such as retry failed items, request another page, or ask for confirmation. These hints should guide the AI client, not replace validation or server-side safeguards. The core lesson is simple. Reliable MCP tools start with reliable interfaces. Define a precise input contract, validate every runtime request, and return results in a stable, structured shape. That gives clients predictable behavior, useful errors, and safer AI interactions. Next, we'll extend this foundation into idempotency, side effects, and safe mutations in production workflows.